start recording. So, hello everyone, welcome. As I said, this is new for me, so please bear with me while I learn how to work everything. So this is a review session on the histology that we covered in second semester. So the alimentary system, the urinary system, reproductive systems. So it's going to be a mix of PowerPoint-based questions. So I have micrographs with things labeled and questions related to those, and also Kahoot questions. So please have your mobile devices at the ready. Feel free to use chat to let us know you're here and that you're participating. It looks like there's so far 64, which is great. It's about half the class. So hello, Seb. Thanks for saying hello. So first of all, we might start with a couple of questions. Let me just click over here. So we'll start with 2 questions on Kahoot. So please go to kahoot.it on your web browser, either on your phones or laptops or something like that. So I'll get this started here so we can actually get a pin number for you guys. Greg Woods joined. Wow. Come and talk to us about Tassie devil facial tumor disease. All right, so there's the pin, 2699621. That noise is, the music is awful. I wonder if I can turn that off. All right, I can start to see people's names appearing. This is great, it's working. Spermatus Zoom, I like that. El Chapo. So 60, we've got 66 people here. What is cell? That is the question. Welcome, Patrick, Miranda, Luke, and the Queen, Your Majesty. So we're just about to start with a Kahoot quiz. So please get your mobile device, laptop, tablet, mobile phone, go to kahoot.it, and there's the pin number. So far, 68 players. We're about the number of people viewing. Again, if you want to say hello in the chat, do so I know you're here. So we'll give 1 more minute to let people join, and then we'll start our first 2 questions before we move on back to our PowerPoint. Hello in the chat. Thank you, Daniel, waving. Jeff, my name is Jeff, saying g'day, folks. Okay, so let's start. And there's a massive picture of my face. All right, from which specific gland does lingual lipase originate? Okay, so the majority of you have got the answer correct. The von Ebner's glands, of course, those are those specifically serous glands associated with the circumvallate and the foliate papillae on the lateral surfaces of the tongue. Remember, lingual means tongue. So the lipase comes from the tongue, and that's obviously a good indicator. So submandibular, parotid, sublingual salivary glands responsible for the main parts of salivary secretion, parotid predominantly for the salivary amylase, and then the submandibular, sublingual for the mucus components of saliva. So von Ebner's glands was the correct answer there. So well done to the 32 of you who got that correct. I know it's been a while since we've done digestive, so you know, this will be a good. Spermatozoom is zooming to the lead, so well done, Spermatozoom, just by 1 point in front of Kev. All right, so second question. Which gland is shown in this video? So this is just a video which I uploaded to YouTube. There's no sound, so don't freak out. It's just me looking at a digital slide box slide of a particular gland, and you need to identify which gland we're looking at. Answers coming in already without us zooming in. You guys are confident. So the timer actually starts from when the video finishes. But if all of you answer in the meantime, that's fine. Okay, the timer started. Okay, so again, the majority of you have got the answer correct. So we sort of show this again. How can we tell whether we're looking at parotid versus submandibular versus sublingual versus pancreas? So you can use a little decision tree, and it's based on your understanding about the composition of those different glands. So both parotid and the pancreas are entirely serous glands. And the difference being, of course, that the pancreas has the islets of Langerhans. So, you know, if you can see an entirely serous gland, let me just pause this here. If you can see an entirely serous gland, then we're looking at either the parotid or the pancreas. But then your next question is, do I see islets of Langerhans? So if you see islets of Langerhans, you must be looking at the pancreas. The other good feature to look for is the presence or absence of striated ducts. Now, there are no striated ducts in the pancreas, but there are very obvious striated ducts in the parotid salivary gland, so that'll be another feature that you can look at. So here, so these are all predominantly the serous glands, and then over here we've actually got mucus acini, and you can see some of these serous demilunes here. So it's predominantly serous, but a little bit of mucus. And so that actually leads us towards the submandibular salivary gland, because the sublingual was predominantly mucus with a little bit of serous. And the serous components in the sublingual exist almost exclusively as these serous demilunes. So the fact that we can see serous acini and mucus acini leads us towards either submandibular or sublingual. The fact that it's predominantly serous leads us to submandibular over sublingual, which is the sublingual's predominantly mucus. So hopefully that helps work out why that's the correct answer, the submandibular salivary gland. So Breg Woods in the lead there. So that's where we'll leave the Kahoot for now, and we'll come back to that after we have a bit of a look at our PowerPoint quiz now. So This is a slide, obviously, H&E slide, with a number of things labelled, and so there's a number of questions there. So take a few minutes, and when you think you're done, how about you just type 1 in the chat so we can get an idea that when it's time to move on and we can talk about the answers there. Okay, if everyone's happy with that, and I'll just mute myself for the moment so that I don't have to, you don't have to keep hearing me. All right, so I'll give you a few minutes to have a look at that. And as I say, when you're done, please type 1 in the chat. All right, I think that looks like the majority of everyone. If not, Seb put enough in for everyone to turn up. All right, so part A, question 1, part A, identify the organ present in this section. So what do we think it is? Let's see some answers in the chat here. Lung. Didn't cover lung in the second semester, so not likely to be lung. Nice to see some Australian spelling of esophagus there. Good. Yep, it's definitely the esophagus. Well done. Oh, why are you sad, PB? All right, so part B, identify the epithelium A, name 2 sites within the GIT where this type of epithelium can be found. So what type of epithelium lines the esophagus then? Good. Yes, dingus. It's got the full proper title. Non-cretinized stratified squamous, also an oral cavity and the anus. Good. Yeah, and that's exactly the answer we were looking for the second part as well. So stratified squamous, non-keratinized epithelium. So if you were to zoom in here, and you might, I don't know how well, you probably can't see it that well, but there's nuclei all the way to the surface. So if we were to see a zoomed in section, we'd see nuclei all the way to the surface, which indicates it's a stratified squamous non-keratinized epithelium. And of course, that indicates that we've got a potential for abrasion in a moist environment. So we find it also in the oral cavity. We're chewing hard material, so we need a abrasive protective epithelium there, and the anal canal, of course. Good. All right. Question or part C, identify the layer B. What do we think B is? Great. Yes, Emily, don't need a question mark. You're absolutely right. It is the lamina propria. Well done, well spotted. So this is the layer of loose connective tissue that sits directly underneath the stratified squamous non-keratinized epithelium. What about part D here? Identify the layer C. C is mucosa, muscularis mucosa. Anyone else? Okay, so C is actually a trick question, so please no hate in the chat. C is actually still the lamina propria, so it's just a continuation of the loose connective tissue here. So it's actually still there. So identify the layer and tissue present at D. So what do we think D is, and what tissue makes it up? Muscularis mucosae? Yes, great, well done. And what tissue? What type of tissue is it? Smooth muscle. Yeah, great. And so the muscularis mucosa, if you remember, we can sort of divide the esophagus into 3/3. The upper third has a relatively poorly developed muscularis mucosa, and then the middle and the distal third has a better developed muscularis mucosa, and that's probably a reflection of the fact that in the upper third, we've got skeletal muscle predominantly in the tunica muscularis, and so therefore the peristalsis is less important because it's a physical movement by swallowing, and then after that is peristalsis, and so we need a little bit more help through the smooth muscle of the muscularis mucosa here. Good. All right. Identify layer E. Submucosa, great. So we can actually just see some blood vessels here. It looks very similar actually to the loose connective tissue here, but we sort of classify it a bit more as dense irregular connective tissue. A little arteriole or small artery there. What's missing from this layer, of course, are the mucus glands. So we can have esophageal mucus glands in the submucosa, but they're predominantly at the apical, well, the top proximal third and the distal third. So that's probably a good indication to think about where this section might be taken from. G, identify the layer and the specific sublayer. F, and what's the primary tissue here? Yeah, good. Tunica muscularis, inner circular layer, great. That's exactly right. And the predominant tissue? Smooth muscle, fam. It sure is. So this is predominantly smooth muscle, lots of nuclei fairly close together, lots of fusiform cells really sort of quite closely adhered together. H then, what is indicated by the arrow? From this, what can you deduce about the origin of this specific section? I know it's obviously very low magnification, very acidophilic cells. So what do we think is indicated by the arrow? Cirrhosis, a good guess. Chicken chow mein number 2. Question, yeah. It is skeletal muscle. So those are actually large. These large cells are actually skeletal muscle fibers. So this is here. This is smooth muscle, and then this is skeletal muscle. So we've actually got a mix of skeletal and smooth muscle, which, as my name Jeff points out, is indicative of the middle third. Yeah, that's exactly right, Irene. Well done. If this was all skeletal muscle out here, then that would be the proximal third. The middle third is made up of a mix of skeletal and smooth muscle, and then the distal third is made up of entirely smooth muscle. Yeah, so that's how you can sort of tell the difference between the three regions of the esophagus there. Does anyone have any questions about anything here or anything about the esophagus before we move on? Nope. Good. All right. So let's move on. Okay. Question 2. So again, I'll give you we'll give you a few minutes to answer these, and let's see how you go. Once again, when you're done, please, if you type 1 in the chat, that way we know it's time to move on. Thank you, Jamie, Chap Daddy. Great. All right. So this is a really nice section, actually. Some very basophilic glands up here, which I probably should shut up now because I'm already helping you answer questions which we haven't talked about. All right, so part A, identify from which organ this section has been taken. What do we think? It's not that easy. It is a little bit of a tricky question because it's quite a high magnification. Yeah, so it is the tongue. So well done, Emily M. Histology, PB, Gretel, AS2, Jeffrey, well done. It is the tongue. We can tell, and this is going to sort of lead us into answering part of these later questions, but these are actually skeletal muscle fibers. So big cells, peripherally located nuclei. In this section here, this longitudinal, we can actually see the striations. So here they're cut in cross section. Here they're cut in longitudinal section. Here they're sort of almost oblique in section because you can see some striations here. And so, sort of to move on, the tissue that cell B comprises is arranged in a unique way in this organ. What's unique about it? we're obviously going to jump the gun here, but the tongue has skeletal muscle fibers arranged in 3 different directions, and that's unique in the whole body. So if you see skeletal muscle fibers like this running in 3 different directions, you must be looking at a section of the tongue, because that's the only place that it occurs in. So well done to everyone. I can see why you might think it's a pancreas because of these glands up here. These are very basophilic glands. So then, knowing that this is the tongue, how does that change perhaps your thoughts about what A might be? So identify the glands labeled A. What is the primary product of these glands? And I think I've just already told you part of that anyway. So not parotid, because of course the parotid is its own sort of salivary gland. It's not associated with the tongue. Yeah, they're minor salivary. So we'd probably call them minor lingual accessory salivary glands. And these ones, because we can't see any mucus acini, we'd say they're predominantly serous because they're so basophilic. But a lot of these glands are typically, the accessory salivary glands are typically mucoserous. We don't know, maybe these are actually von Ebner's glands, because remembering von Ebner's are entirely serous, and they're found in the tongue as well, but they're specifically associated with either the circumvallate or the foliate papillae, but we can't see that in this, this section. Now, this asks to identify cell B. Well, we've done that. That's a skeletal muscle cell, and we've talked about the tissue that B arises is arranged in 3 different planes, which is unique to the tongue. So well done, minor accessory salivary glands. Does anyone have any questions about that? Nope. Okay. Sorry, got to click back on there. Oh, hang on. How do we distinguish between the front and the back of the tongue? Right, so we can actually divide the tongue. So we've got a couple of questions there, so I might just go back. Sorry. How do we distinguish between the front and the back of the tongue? The tongue can be divided into an anterior 2/3 and a posterior 1/3, generally by the line in front of the sort of V-shaped circumvallate papillae being anterior to that is the anterior 2/3, and then the posterior 1/3 is behind that. And in the posterior 1/3, we actually have the lingual tonsil. So this big, massive mucosa-associated lymphoid tissue, these lots and lots of lymphocytes, usually arranged into follicles and so on. So the posterior third of the tongue typically has the lingual tonsil, and the anterior 2/3 won't have that. The other way is depending upon whether you've got a section with a papillae on the surface. If you've got circumvallate papillae, then you're in the posterior 1/3. Otherwise, generally you can't see a tonsil in there. This big, massive lymphoid tissue, then you're probably looking at anterior 2/3. And then Irene's asked, can you conclude they're 100% serous from the section alone, or do you know what type of glands they are? So no, because this is only a small, high magnified section, we know that this part is entirely serous because we can't see any mucus acini. They're all just entirely serous glands here. They may be von Ebner's, or they may be just part of the minor accessory salivary glands, and in fact they're part of the seromucous glands. We just can't see the mucus acini, so you just take a guess at that point in time. Someone's asked us to pause for 2 minutes while they go and pee. So maybe if someone's got another question about that, we can wait a couple of minutes. Hopefully that answers everyone's questions as well. So if you have any other questions, just let me know. It's a bit difficult to stop for a pee break. So we might move forward and they can hopefully catch up either through the recording or in time. All right. So here's slide or question 3, and there's 5 sub-questions there. So we'll give you a few minutes to have a look at that. And then again, when you're done, type 1 in the chat, and then I'll know to come and have a chat. Okay, lots of ones in the chat there, so probably ready to move forward. Obviously, hopefully you've recognized that this is a junction of some kind. So we've got quite a transition here from this epithelium to this epithelium. So part A, what type of epithelium lines A, and name the cell type found here. So what do we think A might be? Simple columnar? Anyone else got something different? Simple columnar ciliated. Simple columnar with goblet cells. Oh, my name Jeff is getting quite angry at the idea that there's goblet cells there. So, unfortunately, we can't zoom in because it's just a micrograph, and I don't think we can, or can we? See if it'll allow me. No, won't let me. I'm sorry. Let's enter full screen, see if that fixes things. It's a little bit bigger, but not much bigger. Magnifying glass on the top left. So let me just first of all do this again. No, can't do it, I'm sorry. Zoom. It's going to be obviously a bit distorted there. So it is a simple columnar epithelium. There aren't any goblet cells, but there are mucus secreting cells. What do we think? What type of cell type then? So if there's no goblet cells, we've got a simple columnar epithelium. Go back to where I came from. Oh, goodness me. Oops. Too blurry. Okay. Right. That's Daniel. That's right. These are surface mucus cells. This is the junction between the stomach and the esophagus. Do you remember the specific name for this junction? Yeah, Emily, well done. Dingus, well done. Yeah, this is the cardioesophageal junction. So we're moving from the esophagus to the stomach. So this is the cardiac region of the stomach. So this is a simple columnar epithelium, and these are surface mucus cells. Good. The epithelium lining B then becomes quite easy. Kill all the juice, that's right, cardioesophageal junction. We just talked about the esophagus, so hopefully everyone knows, yeah, not simple squamous. My name Jeff, stratified squamous, non-keratinized epithelium. Yeah. Oof. Yes. All right. Identify the structures labeled C. What is their function? Gastric pits, cardiac cells, mucus glands, yeah. Cardiac glands, good. Opening for the gastric glands and secretions. Yeah. So, student, they're not gastric pits. So gastric pits are these depressions here. You can see these depressions. So these are the gastric pits, but these are the cardiac glands. Do you remember what type of glands they are? Does anyone remember what type of glands? Yeah, that's right. They're mucus-secreting glands, and they play a part of a role in protecting, particularly the esophageal lining from acid reflux. So they secrete a protective mucus. So they're mucus-secreting glands. So the cardiac glands are mucus-secreting glands, as are the pyloric glands. Good. Identify the specific structure labeled D. Yes, well done, Rosie and Emily. Chicken chow mein. Muscularis mucosae, yeah, that's right. So that's the muscularis mucosae there. So this is then the mucosa, and then this is the submucosa, and then here's the tunica muscularis here. All right, so then this is obviously a section of the cardioesophageal junction. So we've already sort of alluded to that as part of our discussion. All right, does anyone have any questions about that before we move on? I think we're doing another Kahoot, couple of questions. So we're losing a few people along the way. F in the chat because we're losing people. No. All right, so let's move forward then. What features, Emily's asked, what features would point this being an anorectal junction? So what you're looking for there are goblet cells. So there would be goblet cells, big, pale, sort of circular, pale regions, which would indicate goblet cells. And we'd have simple straight tubular glands because the rectum is part of the colon, and it has simple straight tubular glands. So that's the thing that you'll be looking for there. And then at lower magnification, you might see a thickening of the inner circular layer of the muscularis, tunica muscularis, which would be the internal anal sphincter. So those are some of the things. Okay, Emily, I'll have a look if we can find the Kahoot pin. AS number 2, there's no pressure? Oh, the people can't take the pressure. Oh, I see. Oh, thanks, Miranda. So Miranda's typed the pin number for the Kahoot in the chat, 2699621. Thanks for recording that. I should have done that, so I apologise for that. So for those of you who have newly joined, we're doing Kahoot. So if you go to kahoot.it, and then the key or the pin is the number in the chat there. So hopefully you have some time. So we've got one question in this part of the Kahoot, and we'll keep popping back and forth between the two. So let's go to the Kahoot. So everyone ready for the Kahoot? Mobile devices at the ready. So here we go, the next question. Which specific region of the GOT is shown in this video? So remembering the time starts once the video finishes, so don't feel like you have to rush to get the answer. I know everyone's trying to beat everyone, but I am sort of pointing out with my cursor here some of the key features. All right, time has started. Well done, everyone. So it is the body fundus of the stomach. So how can we tell? If we have a look at the video, the best way to tell, or do you want to tell me what made you decide that it was the body fundus of the stomach? What are some of the features that you used to identify it? Thyroid plaque gland, yeah, very, very glandular, isn't it? lots of glands, quite long glands, yep. Pits are not very deep. So the fact that the glands are so deep indicates that the pits aren't going to be very deep. So yeah, the pits are only about 10% or so of the mucosal depth. Shallow pits, the cells. So what about the cells, Sean, did you think? This is really nice here. So this, as we zoom in here, you can hopefully see these nice cytophilic round cells. They look like fried eggs. These are parietal cells. So they are responsible for secretion of the hydrogen chloride ions. And then down the bottom here, we've got the chief cells, or the peptic cells, that secrete the pepsinogen. So of course, those are only found in the body fundus of the stomach there. Great. Yeah, not much coiling of the pits as well. So you can see very shallow pits here, and then lots and lots of packed glands. Little evidence of lamina propria between the glands, which is really indicative of the body fundus of the stomach. Well done. Okay, so Jay is in the front now and just ahead of Daniel. So we'll go back to PowerPoint here. We seem to have minimized. All right, so here's our next question. So again, we'll give you a few minutes to work through that, and then type one in the chat when you're done. Oh, it's hailing. Well, at least we'll be on here for a little bit longer. I don't have to walk to the car park in the hail. Hopefully, we'll be finished by then. Oh, Emily. Hopefully, your tomato plants will be safe. All right. So, part A. Which region of the stomach is shown in this section? So I've given you that it's a region of the stomach. Professor Phoenix's professional opinion is the pylorus. Oh, sorry, Mia. Cardiac. Pyloric, yo. Yeah. So it is the pyloric region. And so let's answer a few more of the questions and we can talk about why it's a pyloric region. So what's A and what type of cells line A? Gastric pit? That's Daniel. That's exactly right. So the gastric pits are actually lined by the same cells on the surface. So they're actually surface mucus cells. When they extend down into the glands, they're actually then known as mucus neck cells. So you might remember I just mentioned about the parietal cells and the chief cells. They're only found in the body fundus region of the stomach. So both the cardiac and the pyloric region don't have those cells. Um, so how does A here compare with other regions of the stomach? So the gastric pits, how are they different in the pyloric region? Deeper. Yeah, that's right. So they're about 50% or so of the entire mucosal depth. So here's the muscularis mucosa here. So if you think about that as being the entire depth of the mucosa, we can see there about 50% or more of the depth is actually made up of these gastric pits. And that'll be one of the really characteristic features you can use to identify this as the pyloric region of the stomach. What is B? It's a bit vague, isn't it, B? Oh, sorry. Emily, gastric pits, and they're lined by surface mucus cells. That's all right, Emily. Don't apologise. That's okay. It's late afternoon. Everyone spaces out late afternoon. Yeah, it is lamina propria, that's right. And so we can actually see the lamina propria, whereas in the previous video, when we looked at the fundus body of the stomach, we could almost not see the lamina propria. But the fact that you can see lamina propria should hopefully point you to either the cardiac region of the stomach or the pyloric region of the stomach, if you of course identified this as the stomach. So are glands most shallow in the body of the stomach? Yeah, absolutely. So the cardiac region has glands around about, I don't know, 40% of the depth, but the body fundus has about 10% of the depth. So very shallow gastric pits in the body fundus. Yeah, that's right, Daniel. Well done. All right, so B is lamina propria. What is C? What does C produce and what is the function of this product? Mucus glands that produce mucus, which protects the stomach from the acidic secretions. Yeah, yeah, so these are actually mucus secreting glands. So these pyloric glands, you can see how pale staining their cytoplasm is, and the fact that their nuclei are flattened basally located, very typical of mucus secreting cells. And they do secrete a protective mucus, not only for the stomach, but also for the duodenum, because of course the pyloric region joins onto the duodenum, so it helps to protect that region as well from the acidic chyme. So if you were asked in the applied exam, I'll get to your question in a second. If you were asked an applied exam to identify C and then name two cell types you might find here, then the correct answer would be mucus, well, obviously naming them as pyloric glands, and then two cell types would be mucus neck cells, because these are basically mucus neck cells, or and enteroendocrine cells are the other type of cell. So a few of you have mentioned chief cells and what was the other cell type? I've just lost parietal cells. They're only found in the body fundus. So if you ever get a region of the stomach that's not body fundus, and you're asked about cell types, it's only ever going to be mucus neck cells or enteroendocrine cells in the glands. So those are the two cell types which we may find there. Now, there was a question. So you have mucus glands throughout the length of the pit. Yeah, so the mucus neck cells extend all the way down to protective mucus on the surface there. Are there Paneth cells in the stomach? No. Paneth cells are in the small intestine predominantly. They may extend down into the large intestine, but predominantly within the small intestine. So are they only called gastric glands in the body? Generally, yeah. So we sort of call them cardiac glands and pyloric glands specific to those regions. And then, I mean, they're all gastric glands in the sense that they're all glands of the stomach, but to be more specific, pyloric glands and cardiac glands for those two specific regions. What does C produce? Produces a mucus, protective mucus, usually alkaline to help protect the surface lining. You're welcome. All right, does anyone else have any questions about that? Okay. Oh, here we go. Oh, no. A lemonade recipe from Mia. Anyone's interested? All right. So this is question 5. This one's obviously quite a short one. So let's see how you go. All right, so hopefully that's enough time. So where do we think this section was taken from? It's a bit tricky, this one, but pancreas, body of the stomach, submandibular salivary gland. All right, so maybe it's easier if we try to identify what A is. What do we think the cells are, A? Big round nucleus in the center of their acidophilic cytoplasm. Yeah. So Rosie and J and AS number 2, parietal. Those are parietal cells. Remember the sort of fried egg appearance? Centrally located nucleus in the center of their cytoplasm looks a little bit like a fried egg if the nucleus was the yolk. And then the egg white on the outside, obviously a bit more pink. Hopefully you don't want pink egg whites. So yeah, these are parietal cells. So we're in the body of the stomach. And so therefore B then, yeah. So if these are parietal, then these are the chief cells. Yeah, big round nuclei basally located. Now in this case, because they're producing an enzyme, we would typically expect that the apical cytoplasm would be acidophilic. But obviously this animal's likely to have had a meal recently and probably has exocytosed most of the pepsinogen, and so therefore it's a little bit more paler staining. But yeah, they have the typical sort of protein producing ultrastructure, so lots of basal rough endoplasmic reticulum, so they're quite basophilic. And then we might see a slightly acidophilic apical cytoplasm, but not really evident in this section here. All right, is that okay? So again, lots and lots of glands stuck together, not a lot of lamina propria. You can see a few fibroblast-like cells. Which cells are more basal? The chief cells. So this is we're heading out towards where the muscularis mucosa would be down here. So you can see we've got quite a acidophilic part on the left here and quite a basophilic part on the right, and that's because the apical portion of the gastric glands from the body fundus region tends to have more parietal cells, and therefore it tends to be more acidophilic, and then the basal portion tends to have the most chief cells, and so therefore it stains largely basophilic. So again, if you get asked why have you got the difference in staining pattern, it's because of the higher concentration of parietal cells in the apical portion of the gland as opposed to the chief cells down the bottom. And of course, they're acidophilic because they've got lots of membranes and lots of mitochondria, both of which attract eosin as their stain. Is that cool with everyone? Cool. Great. All right. So we'll go back to Kahoot. We've got 3 questions. Okay, so we've got 3 questions in Kahoot. Hopefully everyone's got their mobile devices still logged in. If you don't have it, then scroll back in the chat. You might be able to find the key. All right, so let me see if I can find it back in the chat. They're popping up all over the place. There we go. 5 times. Okay, so everyone's ready? Okay, next question. Which of the following is a stimulus for the gastric phase of digestion? So I've moved into physiology. Tricky. Which of the following is a stimulus for the gastric phase of digestion? Okay, so this was a bit of a tricky question because it was actually sneakily a physiology question, which I threw in here. So, you know, you have 3 phases of gastric control. You have the cephalic phase, which is related to the smell and taste and sight of food. Then you have the gastric phase, and then you have the intestinal phase. And the gastric phase is brought about by food entering into the stomach and can be brought about by 2 things. One, it's the stretch of the stomach, which can bring it about, or it's actually the increase in pH. So it's actually getting more and more towards alkaline. And of course, that's in response to more volume in the stomach there. That's right, the tomato is your vagina is a tomato. Got nothing to do with this, but yeah. All right, so hopefully that makes sense. You know, the food moves into the stomach, it dilutes the acid, and so therefore you have an increase in pH, moving it closer to the alkaline, and therefore that's a stimulus to stimulate the gastric phase of digestion, which includes gastrin being secreted, which then stimulates HCl secretion and pepsinogen secretion from the chief cells. All right, Kev's taken the lead over spermatozoom. Next question. Which of the following is not a means of increasing the surface area of the small intestine? Oh, look at that. Well done, everyone. So yeah, tinea coli, of course, is the arrangement of the 3 bands of outer longitudinal layer of the tunica muscularis in the large intestine. Microvilli, plecocircularis, or circular folds, and villi all increase methods of increasing surface area within the small intestine. So plecocircularis, the queen, are those circular folds. Those are the permanent folds of the mucosa and submucosa that are found in the small intestine. We do have similar folds in the stomach, where of course they're known as rugae, and we have folds in the large intestine, but those are non-permanent folds. Right, Kev's still in front, and we've got one more question. What converts trypsinogen to its active form trypsin? Again, this is sort of leading a little bit into physiology. Didn't really talk about it in histology, but I thought I'd throw in a few curveballs. Ooh, okay. So where does trypsinogen come from? What secretes trypsinogen? Yeah, it's the pancreas. So it's actually the inactive form or one of the proteases that's released by the pancreas. So it's released by the acinar cells, and it's released into the small intestine where it comes into contact with the brush border enzyme enterokinase, which converts it to trypsin, and then it's trypsin which converts all the other proenzymes, so the chymotrypsinogen into chymotrypsin and so on. So interaction with hydrochloric acid is what converts pepsinogen into pepsin, but it's actually this brush border enzyme enterokinase which converts trypsinogen into its active form. So Kev is still in the lead as we go back to our PowerPoint slide. I am aware that we're running out of time here, so we might need to be a little bit quicker because we've still got quite a few questions to get through. So we'll try to move a little bit quicker. All right, let's have a couple of minutes to see what you can answer with this. Again, type 1 in the chat, please, when you're done. Okay, thank you, everyone. So, part A, which specific region of the GIT is shown here? Large intestine, appendix, ileum. Okay, so for those people saying ileum, if this was ileum, what would he expect on the surface here of the mucosa? Yeah, so if this was the ileum, we would expect to see villi, and we don't see villi. You can see it's relatively flat, and so it's not the ileum, but it is the appendix. So the fact that we've got a flat surface with this mass of mucosa-associated lymphoid tissue is an indication that this is the appendix. Which region of the GRT is it considered a part of? Well, it's obviously part of the large intestine. So you might be able to see there's a few simple straight tubular glands. If we were to zoom into these, which we can't unfortunately at this point in time, but if you were to zoom into these, you would see goblet cells, and they're typical of the colon histologically. What type of epithelium lines its surface? So what do we think? What type of epithelium lines the appendix? Yeah, not quite, Emily, but it is simple columnar. So remembering, you might remember my sort of take-home message from the first lecture on the gastrointestinal tract, that there's two epithelia which exist within the gastrointestinal tract: stratified squamous non-keratinized or simple columnar. And so this is a simple columnar epithelial lining. If we were to zoom in, we'd see a simple columnar epithelial lining. Identify A. Yeah, in AS2, you're very specifically correct. So this is actually a follicle, and in fact, it's a secondary follicle. So we can tell the difference between primary and secondary follicles by the presence or absence of this pale center to these circular arrangements. So this is considered a follicle. Now, if this is a primary follicle, we wouldn't have this pale center. The secondary follicle is indicated by this pale center here called a germinal center. And that indicates that it's been stimulated by an antigen and that these cells are actually converting into plasma cells. So the B lymphocytes here are transforming into plasma cells. So they're not Peyer's patches. Peyer's patches are specific to the ileum. And that actually leads us into part E, name one other side of the gastrointestinal tract that displays similar characteristic basophilic tissue. So really we can have MALT anywhere along the length, but the ileum has those permanent aggregations of MALT, like the appendix does. And so you would have a region of normal small intestine with villi and so on, and then you'd have these aggregations of this sort of typical follicle structure associated with the Peyer's patches. Is that okay? Does anyone have any further questions? Where can we find GALT? Well, GALT is just another name for MALT. So a gut-associated lymphoid tissue is what GALT is. So we can find it anywhere along the length. Tonsils, they're also part of MALT. What about salt? That's what you put on your chips. So is this a primary follicle? No. So a primary follicle wouldn't have this pale brown region. So that's called a germinal center. So a primary follicle would be just more like this. You can see how it doesn't have this sort of round pale center here. So this would be a primary follicle, and then these are secondary follicles. They've been stimulated by an antigen, and so the cells are transforming into plasma cells there. Sorry, my name's Jeff. I didn't notice that you had your hand up. Did I miss a question? Sorry about missing your hand up there. Is MALT the same as secondary? So secondary follicle is found within MALT. So you either have primary follicles or these secondary follicles, depending upon whether they've been stimulated by an antigen. It's all just the same. It's all part of MALT. You find a similar sort of structure within a lymph node as well, and some of the lymphoid organs. So if you have this pale center region here, it's known as a germinal center, and it indicates that the B cells have been activated by an antigen. So antigen presenting cells have probably come in and activated the B cells to transform into plasma cells. We didn't really get much time to talk about lymphoid tissues and things along the way. So I understand that, this might be new to you, and certainly I won't examine you on that. So I've gone into a bit more detail here than you probably really need to know, so I apologize about that. So if everyone's happy, we can move on. Yeah, okay, great. All right. A little bit of more self-promotion. I know you guys love it. So I'll give you a couple of minutes to answer these questions. Again, type 1 in the chat when you're ready to go. Your heart is a muscle, but it is also lined by epithelium, simple squamous endothelium in the middle and on the outside as part of the visceral layer of the pericardium. Gang of youths. All right, good. Thank you for letting me know you're done. So which model of liver lobule structure is shown in this video screen capture above? Portal lobule? Yeah, great. Yep, so that's the portal lobule, where the center of focus is this region here, which of course is the portal triad or the portal region here. So then what does this model consider in terms of liver structure and or function? Yeah, great. Yeah, you guys have got this. So all of the cells then in this parts of the triangle, well, all of their bile that they produce would drain down into the bile ducts, which are found in this portal triad region here. So all these cells would drain into this bile duct in this region here. So it's sort of the opposite flow of blood supply, which would be running towards the central vein region. So it could also consider lymphatic flow. Gretel, that's right. Well done. Um, so the focal point is the portal triad or the portal region, and inside there we've got a branch of the hepatic portal vein. We've got a branch of the hepatic artery and the bile duct there too. And then the other two liver lobule structural models, everyone had them ready to go. Just waiting to type enter. Liver acinus in classic lobule. That's exactly right. So the classic one is the sort of way histologists think about the structure of the liver. And then the liver acinus model sort of considers this region here as the focus, and then we sort of divide it into three zones: cells in zone 1, cells in zone 2, cells in zone 3. So it's sort of a oval kind of shape, I suppose. And then the cells in zone 1 receive the blood, so it sort of considers perfusion rather than anything else. And the classic module is more about just normal liver structure, this sort of lobule-like structure. That's right, liver acinus is the most clinically relevant because it considers perfusion. And so someone with low oxygen, well, the cells in zone 1 won't be so affected, cells in zone 2 moderately affected, and then cells in zone 3 may experience apoptosis or necrosis. Yeah, that's right, Emily. Well done. Well done, guys. You guys seem to know the liver acinus model really well. So well done to you guys. You are amazing. I do think you're amazing. Right. Does anyone have any questions about that before we move on? Sean, what's for dinner? No questions. Right. Right. So we're going to go back to Kahoot. Ribs. All right. So everyone's ready for Kahoot. We have about 12 minutes to go. Right. I'm going to click next. Next question. Which of the following is not present in the gallbladder? Yeah, good. So the gallbladder consists of a mucosa, a muscularis, and a serosa. So it's lined by a simple columnar epithelium, but it doesn't have a muscularis mucosa. So it might be mistaken for the small intestine because it has those folds, a bit like villi, but it doesn't have goblet cells and it doesn't have a muscularis mucosa. Well done. Right. Kahoot has come from nowhere to take the lead. All right, next question. Which of the following histologically distinguish a section of colon from the rest of the GIT? So what's specific to the colon? Yep, Well done. So simple straight tubular glands, if you can see a gland that has a lumen all the way from the top to the bottom, then you must be looking at a section of the large intestine or the colon. Non-permanent lymphoid nodules can be found anywhere throughout the gastrointestinal tract. Intestinal glands with goblet cells are found in the small intestine as well. And we do have folds in the mucosa and submucosa in the stomach. They're the rugae, and in the small intestine where they're the plicae secularis or the circular folds. So simple straight tubular glands are a way to identify the large intestine. All right, and I think this will finish us off for the GIT. We spent a lot of time. I probably got too many questions on the GIT. I should have spread them out a little bit more. So which junction of the GIT is shown in this video? Once again, the timer will start. It's only a minute long. I'm pointing things out with my cursor. Oh, a tricky one. Yeah. So can I give you one big clue so that you're ready for the applied exam? I don't have a section of the ileocolic junction. So I'm not going to put that in the exam. So there's a big clue for you guys moving into the applied. It was a pyloroduodenal. So one big feature to look for is this thickening of the inner circular layer. That's a pyloric sphincter. Okay. Then if we have a look here, we've got these mucus secreting glands with very deep pits. So this is the pyloric region of the stomach. I sort of point out the depth of the pits over here particularly. So if we think about the mucosal depth, we can see the depth of the pits here. And then sort of as we jump forward, we've got these villi and then the presence of goblet cells for the first time. So you can see a very classic goblet cell appearance. Also Brunner's glands, Vivian says. Yeah, I don't know if you will see them, but I don't know if they were visible. Let's zoom back at the low mag. Maybe they're visible here. Over here, yeah, you can actually see them in the submucosa over there. Well spotted, Vivian. I didn't even point them out in the video, so you've got very good eye there. Yeah, if you go very far to the left, you can actually see them. So it was very well spotted. You might have to have a look at the digital slide box, see if you can actually see them when you're at time. All right, so Kahoot takes the lead there. So let's keep moving forward. We're going to run out of time here, guys. I'm really sorry about that. I think this is scheduled to finish at 5, and I don't know if we can keep going or not after that. But anyway, have a few minutes, see what you can answer with this. Maybe we can sort of speed through them a bit more. We must finish the Kahoot, I know. You're catching up, good. Yes, Irene, I'll make this available, and I'll make it available with all the answers as well as for the Kahoot. I've actually got all the Kahoot questions in as well, so I'll make all that available. I'm not going to whisper for you, Jennifer. Part 2, you want another one of these? All right. Well, I suppose we can do that. Just let me quickly check my timetable. So we can either do it, I suppose, during study week or tomorrow. What we got tomorrow? Yeah, I don't have anything on tomorrow. Would you guys be happy to do it? Oh, you want swap back? Okay. No, that's fine. I'm happy to come back and finish this. So I won't release it yet. So if I do it tomorrow, then we can record it again. And then those of you who unfortunately can't make it tomorrow, you can watch the video and still, have a guess at the questions and so on. Obviously, you won't be able to participate in the rest of the Kahoot, but yeah. Please not before 3. Yeah, that's fine if we do it at 3:30 again. Is that all right with you guys? Great. All right. So do you want to discuss this? And that's where we'll end it, or we'll start with this? We'll discuss now. Right. Let's finish this one. Okay. Sounds good. Bye, Claire. Thanks very much for coming along. I hope you found it fun and useful. All right. So then, getting back to this slide then, from which specific region has this section been taken? Thanks for that information, gang of youths. TMI. Yes, Vivian and Daniel and Zach. Yes, well done. It is the renal cortex. Well done, G Hill. And Fibrino. Jennifer. Well done. Yeah, so it's the renal cortex. So my name is Jeff. Thank you. Identify the structures labelled A and name 2 structures that may be found in these structures. So what are they first of all? What's A? Yeah, you guys know your renal histology really well. Well done. Yeah, they're medullary rays. And so what are a couple of the structures that we can find within there? Yes, histology. Collecting ducts, loops of Henle. That's exactly right. Well done. CD and loops. That's right. Well done. You guys are really killing it. I'm really impressed, guys. All right. So C then, identify the regions labelled B. Name 1 structure and 1 blood vessel found in the region labelled B. You are still amazing. That's right. No, Jennifer, don't think you're going to fail. All right. So what a B? Cortical labyrinth. And good on you for typing it correctly, because it's not an easy word to spell, labyrinth. It's a bit like rhythm. I can't spell rhythm either the first time. I have to work it out. Labyrinth. That's right. And 1 structure and 1 blood vessel? Yeah, I wouldn't want to put you through that, Jennifer. Yes, well done, Emily. Glomerulus is a correct answer. Afferent arteriole, correct. Daniel, well done. Proximal convoluted tubule, yes, well done, AS2. Oh, well done, Sean. You spelt rhythm. Hopefully, first go. I find it difficult to remember where to put the Y and the H. Anything else in cortical labyrinths? Yeah, afferent, efferent arterioles, peritubular capillaries, perfect. Yeah, that's right. And then one thing we've missed, not the proximal convoluted tubules, but the distal convoluted tubules, good. And the blood vessels which supply the afferent arterioles? Yeah, that's right, interlobular. Some textbooks actually call them cortical radiate arteries. I don't know if you've come across that term before. Yeah, that's right, dingus. Um, so guys, you guys know I run. I'm coordinator of another unit, anatomy physiology, and the textbook we use for that calls it cortical radiate, and that's the first time I'd actually come across that term. But yeah, interlobular, cortical radiate, they're both correct answers. Well done. All right. Well, then that's where we'll leave it. Thanks very much for coming on. I really appreciate your input and being really participating. I do like Final Cut Pro. um, oh, no problem. It's my pleasure. Um, I've actually got a teaching development grant in at the moment where I'm hoping to do some live streaming next year, make it a weekly thing. So that'll be cool. No, no, yeah, I might try Twitch or YouTube. We'll have to check it out. All right, so let's say same bat time, same bat channel tomorrow. I'll make sure I'll put that up in the tutorial folder so you can join again and we can finish our look at the urinary system and also the reproductive systems. All right, thanks very much, everyone. As I say, it's been really great, and hopefully you found this useful. Have a good night, everyone.